Hello, my name is Mike Mims. I'm the president of CDS Incorporated, the developer of the Asteel structural steel detailing system. This video is a demonstration of the Asteel 3D modeler. In this video, we will introduce the basic modeling concepts of Asteel and demonstrate just how quick and easy it is to detail with Asteel. So let's get started. This is the Asteel 3D toolbar. I'm going to start by creating a new model. We'll give the model a job number. Whoop, 17-309. Select a fabricator code. Click OK. Asteel creates a new model with an XY axis, an origin point, and a north arrow. North is pointing straight up and the origin is at 0, 0, 0. If for some reason you want to edit that origin, you could put any coordinates you want in here to maybe match up with the datum point on a project you're working on. And of course you can select any direction for north or type of direction in degrees, exact degrees in the box. We're just going to leave north straight up for this presentation. Okay, now the first thing we're going to do is create our grid. We do that by placing column lines. The column lines have to create a new view to put the column lines in. So we'll go New View, Column Lines. Okay. Now we have a view for our column lines. We'll make that current. And we're going to draw one vertical column line. So I'll pick the start point at the origin, and then I'm going to plug in 60 feet for the Y coordinate. Basically going to draw a 40 by 40 building, so that's just the end point is where the bubble is going to go. So I'm going to label that column line 1 and draw. Now I'm going to do the same thing with a horizontal line. So I'll put the 60 feet under the X coordinate and we'll call this line A, draw. Okay, there's our horizontal and vertical column line drawn in. The easiest thing to do on most projects is draw one vertical, one horizontal, and then offset from those. So we have our offset column line tool. You can either select your column line from the drop down list, or you can actually pick it. We're going to select column line 1 and we're going to offset to the right 20 feet. Asteel uses the convention of feet space inches space sixteenths for entering all dimensions. Makes it simple to input. And so that's going to be column line 2. Click draw. We're going to keep going with 3. We could be changing that 20 feet to something else, but I'm just going to keep it simple. Now we select column line A. We're going to go above 20 feet, and we're going to call that B. And we'll draw another one, call it C. There's our basic grid. Now we can start placing columns. So I'll pick the Place Column tool, opens the Place Column dialog box. We're going to make a view to put our columns in. So we'll click New, Column Tier. We can have multiple column tiers if we want. This particular job is just going to have one, so I'm just going to call that Columns. And I'm going to select the color red for my columns. Okay. Now we'll make column view the current view. And we're going to put a column size in there. I'm going to put 10 by 49. Notice I don't, this is a shorthand method. It assumes it's a W shape. So all you have to do is put 10 space 49. Once you hit tab, it formats that for you automatically. If you have any question as to how to enter sizes, you just hit the little question mark there. And it lists all the different sizes Asteel recognizes and how to input them. So it assumes W. If it's any other type of shape, you have to put the prefix in. Okay, so we can orient our column however is necessary just by clicking around the compass, or we can actually type in a particular rotation angle. I'm going to leave face A to the west. Now we're going to put in our elevation at the bottom. I'm going to go -2 feet and then plus in 2 inches to account for the grout. Then our end type is type 68. This is our common base plate type. We click the little icon here and we go in and we see an example of column end type 68. We click the next button. We have our option sheet. That's the way all the connections are set up in Asteel. We have hundreds of different connections you can choose from. Each one has an example and each one has an option sheet so that you can customize it for the situation on your particular job. Okay, this one, the A dimension is going to be 8 inches from the center line to the edge of the plate, 8 inches. The B dimension is also 8 inches, so from the center line to the other edge is 8 inches. Asteel assumes it's going to be a symmetrical plate. If it was not symmetrical, you could add an I or a J dimension. Same thing with the hole pattern, C and D. We've entered 6.5 inches. C is here from the center line to the center of the holes, and D is from the center line to the center of the holes in the horizontal direction. If it were not a symmetrical plate, you could add L and K and R and Q if you had some extra rows there. The plate thickness is E, 1.5 we have for that, and the hole size F is 1 5/16. So we're going to use 1-inch anchor rods. So we'll just save that. Okay. And we're going to put the top of the column at 18 feet. We're going to have one floor on this simple building, and it's going to be at 18 feet, so we're running the columns all the way up. Now all we have to do is pick our points. So first I'll pick a point right here at the origin, this corner, and you just click Draw. And you'll see I'll move my move this out of the way so we can see it. And there, drew the column in. I'm going to pick another point there, draw, pick another one, draw. We can pick multiple points if we want. So I'll pick there, there, right click, draw. Change the column size. I'll make it a 10 by 54 and pick a couple more places. I'll actually do a multi-pick. There, there, there. Right click, draw. Okay, now I'm going to put a tube, HSS 8 by 8 by half. I'm going to put that right in the middle. Click Draw. Okay, there's all our columns in. Now say I wanted to rotate some of these columns. I could have rotated them when I placed them, but if I forgot to do that, I can just go back and do it. Hit the Edit column. I'm going to rotate that way. And I'm going to do one more over here. Save. Okay, now these toggle switches are the elements of the objects in the model. Okay, objects in the model are columns, beams, any structural shape. Even the column lines are actually Asteel 3D objects. So we have the wireframe is WL is for the wireframe model. The work lines is what WL stands for. That's the most important part of the model. That's where all the connectivity occurs. So the work lines in this wireframe model intersect, and that's where connections are formed. The cardinal line and member line have to do with where the actual member is located, and of course the solids. We also have a beam cross section and a column cross section, which if you have the solids turned off like I do now, you can turn on the column cross section and you just get a 2D representation of the column for orientation purposes. And that's handy when you're modeling in your beams, for instance, if you have the solids turned off, there's not as many places that you can inadvertently pick your points. So you want to be careful to pick your points. We've drawn a circle right at the center of the columns, so it makes it easy to pick that center of that circle when you're placing your beams. Okay, so I'll turn the solids back on, and so we've got all our columns in. I'm just going to edit one of these columns. One thing I'll show you is that we do have a default anchor bolt type, so it did put anchor bolts on all these, and that was the type 1. Of course, you could change it to any of these other anchor bolts if you want, hook anchors or etc. This particular one is a threaded rod with nuts at both ends and also a leveling nut. You can optionally have a leveling plate. Of course, you can specify the rod diameter and the grade and the mark and of course the length and how much thread at each end and how many washers and nuts to use and what type of washers and nuts. So once all the columns are placed, we can go ahead and create an anchor bolt plan. We're into it about 5 minutes, and we're going to go ahead and make our anchor bolt plan. Okay, so here's our anchor bolt plan. You can see all the anchor bolt patterns laid out, and each one is labeled with the member size and the detail, appropriate detail, the bottom of base plate elevation, and the anchor bolt mark. And you know that because there's a key down here that tells you what everything means. Here's our north arrow pointing up, and here is our detail of our anchor bolts. You can see we've got a leveling nut, we've got 2 inches of grout, and the mark is AB1, it's a 1-inch round bolt, and it's referring to the plan for the elevation at the bottom of base plate. So looking at the detail, AB1, there's 36 of them, and there's the detail for the shop. Going back to our model, we can go ahead and start placing some beams. I'm going to turn the solids off, and I'm going to select the place beam icon. We're going to make a floor to place our beams on, so we go to model views, new, floor, and we're going to put the floor at 18 feet. We're going to select the color blue for the floor, and we're going to name the floor second floor. Okay. Now we're going to make the second floor our current view, and we're going to start putting in some beams. So I'm going to pick the start and an end point of each beam. Just make sure you snap to the center of that column. Click draw. We've drawn our first beam in. Now you can go in a continuous line where the end point for the previous beam becomes the start point for your next beam. So all you have to do is pick the end point and draw again. And I'm just going to close that up now, and you can turn the solids on so you can see that we've got a couple of beams there. Now of course we can look at 3D. This is always in 3D, but we're just looking at a plan view. So we can look at a southeast isometric, and you can see your beams there. And of course we can orbit around the free orbit, move it around any way we want. Of course there's various ways you can shade this so it looks more realistic, visual styles, realistic. And I'm just going to put it back to 2D wireframe. And we'll go back and look from the top. Okay. Now to continue placing beams, we've got lots of tools, shortcuts to make things easy. For instance, we can copy beams, so I'm just going to select a couple of beams here, and I'm going to copy from this point here to origin, And I'm going to copy those two beams up to this point. Click Draw. Now I can actually copy them again up here. Draw. And close. Okay. So now we've drawn some beams in there. Now let's put some more going the other way. Let's make this 21 by 44. Pick this point. That point, draw. And we'll make this one a 21 by 55. Let's pick the end point. Draw. And now I'm going to put some 14 by 22s down the middle. Okay, now I'm going to go ahead and copy this line of beams, this point over to this point. And every 15 minutes it reminds you to save your model so you don't lose your work. You notice that the flange is cut down to fit into the column flange automatically. Okay, now let's use our offset beam command. So I'm going to put some filler beams in. So I'm going to select this beam to offset. And I'm going to go below, which as the text is written, that's what we're calling below in this direction. And I'm going to go 3 spaces at 5 feet. So I'll just say draw. And there they are. Now I'm going to do the same thing down here. And then I'm going to actually select the same beam again, and I'm going to go above and fill up that bay. Now on this one I'm going to do something a little different. I'm going to place a beam, and I'm going to make that a 16 by 36, and I'm going to go from the midpoint of that beam to the midpoint of that beam, so we can see what a skewed connection looks like. You can see it put in a skewed shear tab, and it clipped. This is represents the top flange, and this is the bottom flange, so it cuts your flanges for interference there. Alright, let's put one more beam. We'll do an offset member again. And I'm going to select this one, and I'm going to offset one space, say 7 feet. And that's a good mistake you can see I made there. I offset it in the wrong direction. So what I'm going to do there, I'm just going to edit member. and just delete that one. Now let me try again. So I'm going to offset, select the member to offset, and I want to go above, 1 space at 7 foot, draw. Okay, there's our beam we've drawn in. Okay, now that's our basic model just for demonstration purposes. Now we can actually produce some shop drawings. So we go to Create Drawing Dialog, and we'll do the columns first. Drawing number 1, and we just select the members we want. So make that column number 1. Save. These are this is a 1A format, which was 11 by 17, so just one piece on a sheet. We also have a 6-beam format, or 2 columns per sheet. Have various formats I'll get into in another video, but have various formats depending on the fabricator's preferences and how complicated the piece is. You may need to put less pieces on a sheet if it's really complicated. Okay, sheet number 2. Let's make this column right here, and then we'll do a couple of beams. Sheet number 3, can do this one, and sheet number 4, that one, just for demonstration purpose, so we have a few pieces to look at. Okay, so go ahead and process those sheets. So the columns, create drawings. This takes the information from the model and creates a 2D shop drawing in DXF format. Okay, and the beams. So this gives you total control over what you put on a sheet and what sequence it's in, the sequencing. The detailer decides what order he wants to detail and what pieces he wants to put on what sheets. Okay, close. All right, we're just going to close up that anchor bolt plan. And we go to this little icon, gives us our drawings and plans. So our anchor bolt plan is over here under plans. We can also make floor plans and elevations to use as e-sheets. And we'll just open up a couple of these guys. Okay, here's the beam sheet showing the shear tab, and here's the layout of the shear tab. We throw it down off the sheet there so that you can just move it wherever you've got room on your sheet to keep it from having any overwriting cleanup necessary. Okay, and the column, fairly simple column. There's our base plate. Here's the layout of the base plate. Of course, the shop bill's filled out. The weld is automatically applied on the base plate. This particular weld that we chose, it sizes the weld based on the material thickness, but we've asked it to use this typical weld where you're welding one side of each flange, and then you're welding both sides of the web, but only half the depth, so 5 inches on a 10-inch column. So there you go. That's a simple presentation of the Asteel 3D modeler, and in our next video we'll get into some more depth with some more complicated examples, including some vertical bracing, and we'll also go over the output that Asteel is capable of, which includes CNC production control data, plate duplicator, plate burner files, all the files you need to get the job done. Thanks for watching.